My name is Christopher Saldaña, as was mentioned, and I am a faculty member in mechanical engineering here at Georgia Tech. And I'm here to speak today about how mixed reality is changing the manufacturing shop floor. What are some of the opportunities that folks here in the region can participate in order to access some of these cutting edge technologies through the cool work that's being done here across our state. So we'll get started and we'll have plenty of time at the end for any questions or discussion that folks might want to bring to the table. So in terms of our agenda for today, what I hope to do is give you all an introduction to augmented reality, virtual reality, mixed reality, and what's going on here at Georgia Tech and across the broader research enterprise here in Georgia to bring these technologies to not only large manufacturers, but also to small to medium manufacturers here in our state and in our region. We'll talk about how these different terms that are being thrown around by different marketing agencies, how they kind of combine together to give us an understanding of how these technologies can improve the way that we do work within our manufacturing organizations. We'll introduce some different technologies for those of you that might not be familiar that are currently available and others that are coming down the line and how folks are adopting them in their operations. We'll talk about some of the capabilities for authoring these kinds of materials. What are the workforce requirements for bringing in these technologies into your facilities, as well as what are some of the cool applications that folks are using right now, as well as other future applications that we envisage as we start seeing advancements in this space from hardware and software developers. And then finally, we'll wrap up with some regional opportunities that folks here can participate in to hopefully test out these technologies and get familiar with how they might impact your operations. So here at Georgia Tech, we work really closely on the academic side with Georgia MEP. We want to thank them for hosting this webinar. Sean Madhavaraman is one of the project managers there in Industry 4.0 and is a lead on Industrial Internet of Things, process automation and control, and manufacturing analytics. And encourage you all to reach out to him and to me to talk about some of these cool opportunities in AR/VR. So I just have two slides here to just give some context to what is going on here in Georgia in terms of advanced manufacturing and how augmented virtual reality, some of the investments that have been made here by our organizations, I think give folks that might be here on the call and your network opportunity to access these technologies. Part of the challenge with augmented and virtual reality is some of the costs associated with trying these technologies and getting them into your shop and actually seeing them in your application space. And hopefully what you can take away from here is not only an understanding of these technologies, but also some of the resources you have available to you here in the state and locally. So here at Georgia Tech, one of the faculty members that are part of the AI manufacturing pilot facility, and this is a facility here in Midtown Atlanta, where folks such as yourselves can come in and actually, in an open model, come and use these technologies. The federal government has invested in trying to establish these relationships through the MEP and through Georgia Tech with small to mediums, and giving you access to all the different technologies you see here. And the focus of this particular workshop and webinar is on augmented and virtual reality. So what you'll find here is a space for your employees and folks that are leading these initiatives to come and try things and do that in a space that is non-competitive and a place where we all can learn from each other in terms of these new techniques. If you are a provider of these technologies, it's also a place where you potentially can showcase your efforts and help educate your customer base here locally on these technologies as well. I just have one short video here to play related to the facility, and then we'll get started with the webinar. So I'll play this and we'll get moving after that.
It's time to start building up, building back, and building better. Right here in Georgia, we're working to transform communities through projects that will kickstart job growth and through the development of new technologies that will not only enhance America's global competitiveness, but also create a more robust economy long term. Our focus is the intersection of manufacturing, artificial intelligence, and innovations that drive economic development. This project is called the Georgia Artificial Intelligence Manufacturing Corridor, also known as Georgia AIM. With partners across the state, this corridor will bring together rural communities and urban ecosystems, Georgia's diverse universities and technical colleges. And together, we'll activate AI technology to ensure the resiliency of America's manufacturing sector from future shocks and global competition. Georgia AIM will revolutionize the industry economies of Georgia and the nation through the equitable development and deployment of talent and innovation in artificial intelligence. And that's for manufacturing sectors from energy and aerospace and flooring to food production. Georgia AIM will take on supply chain challenges and prove that disruptive AI manufacturing innovations can forever transform our country's industrial economy for the better. We'll support incubators to empower ideas from people that haven't always been brought to the table. Diverse communities will see the benefits of Georgia AIM, specifically underserved Black and brown urban communities and rural Georgia communities of all demographics, as well as active military and veterans, women, and people without a college degree. Our programs will reach every corner of the state of Georgia, from the biggest cities to the smallest towns. Education is also a key component for Georgia AIM, starting with students K through 12 and all the way through college. This will help us meet a critical business need to provide the highly skilled workforce and advanced technical training for the manufacturing jobs of today and tomorrow, especially as they relate to artificial intelligence. The AI manufacturing pilot facility at Georgia Tech will provide Georgia AIM and the nation with world-leading proving grounds for industry, government, and university partners to pilot trials and innovation of new technologies that will advance AI manufacturing and transition industry practices to new, exciting, and efficient ways of working. Collectively, Georgia AIM projects will develop the upskilled talent and high-tech innovations necessary for AI manufacturing to move our state and America forward. Innovating faster and stronger will not only create jobs, but will keep jobs right here in America. We're ready to build back better with the power of artificial intelligence. It's time.
So I wanted to play that so you have some understanding of the opportunities here in Georgia, and we'll come back to how that particular opportunity, the Georgia AIM corridor, is changing the physical infrastructure here in Midtown Atlanta to provide access to these different kinds of technologies. But we'll come back to that. We'll get started with a brief introduction to augmented reality, mixed reality, and virtual reality, and this umbrella term of extended reality. So AR, MR, VR are all various forms of immersive technologies that can alter our perception of the real world, and they share similarities. Augmented reality focuses on enhancing our real world environment by overlaying digital information or virtual objects onto it. Mixed reality, in comparison, is an extension of augmented reality and goes beyond just overlaying virtual objects in a physical world, but actually enabling those virtual objects to interact with that physical environment. Virtual reality, which has been around for a long time, and I think most of us that have familiarity with this may be most associated with some of these technologies, involves complete immersion of a user within a completely simulated digital environment. In this case, they don't have any perception of the outside world, and all the information is being projected directly into their field of view. And generally, what we're going to be focused on today is this concept of mixed reality and how it blends the real environments and the virtual environments through the use of information that's projected onto your field of view. What we'll find is that different hardware platforms and software platforms are capable of specific aspects of each of these, but we're starting to see more emphasis on the use of mixed reality in production environments where you can hopefully improve how workers interact with their physical world through digital information. So there are a couple of different focus areas that we'll hit on here, but I wanted to set the stage before we get into the different technologies that we've highlighted for today. There are two general areas that we focus on here at Georgia Tech and that we are going to talk about later today in terms of some of the technologies that are at play. One is immersive collaboration, and this is where we're starting to see a lot of investment from companies such as Meta and Microsoft in how diverse teams and disparately located teams can interact together to actually collaborate. How do you have telepresence in a group environment where potentially you might see an avatar of another person within your physical environment, and they can see similarly an avatar of you in their environment? And what kind of opportunities does that open up for collaboration on things like troubleshooting, potential training, and different things along those lines? Additionally, we also look at immersive training and immersive work instructions. So training is a very important part, I think, of many of our organizations. How do you do training today? Maybe different than it will tomorrow, might be very different than what it looks like today. And augmented reality, virtual reality, and mixed reality provide an opportunity to do completely immersive training where you can provide instructions directly onto pieces of equipment. You can actually project that information onto that equipment. Additionally, you can also look at work instructions where your workers may be moving toward checking off various aspects of a checklist as part of a work order. That can be done now using these technologies, and we'll show some examples of that. This also opens up unique opportunities for artificial intelligence, and the reason for that is that we have a lot of information that are coming from these different headsets. They have sensors, they have cameras and accelerometers that are tracking information about how the user is interacting with an environment. And the opportunity now is to mine that information and potentially improve how we do training, and potentially also show issues as they come up to the user. So we'll talk about a couple of different examples. This is to show some examples of what we're doing here at the university, but looking at projecting these information into the field of view using these different techniques. Here, you can directly annotate information in a user's field of view and show it to them directly through this overlay. And this opens up unique opportunities for, obviously, better retention of information as you do training, as well as potential opportunities for asynchronous training where workers can come in and actually learn directly on equipment without a trainer there. And that's what we look at here at Georgia Tech as we try to upskill our students on different pieces of hardware. So there are different technologies that are available. We'll review only a few of them. This is a rapidly evolving space. So if there are others that we don't talk about today, I'd be glad to hear about those in the open Q&A. But when it comes to the different technologies, we can split them up in terms of the hardware that are involved as well as the software that are involved. On the hardware side, depending on how you've implemented mixed reality, virtual reality, or augmented reality, we look at the way that information is presented. So we have headset-based technologies that we'll talk a lot about today. That in this case, the user is wearing that piece of hardware, and information is being presented to them as they are in some environment, whether that be the actual physical shop environment or at their desks working on in a controlled office environment. We also have projection-based augmented reality platforms where you can project information directly onto an object, a physical object, or a work surface. And this provides a little bit different experience where the user is no longer actually wearing the augmented reality technology, but that's a physical structure that is using projection systems to project light onto work surfaces. So they have relative strengths and benefits associated with that. A final one that we'd highlight here today is tablet-based AR, or where you have mobile devices that have the capability to, through the camera technology that's built into these devices, show a pass-through of digital information onto the display of the tablet. So a good example of this are, for those of you that might have played Pokemon Go on your mobile phones when it was really popular, that's a good example of the beginnings of mobile-based AR, tablet-based AR. But now you do see the application of these in the work environment, and we'll talk about those. There are other ancillary technologies that are necessary to be involved in this space. Very common ones would be computing hardware and advanced graphics processing units, video cards that can handle the renderings associated with this. So in some cases, if you are developing and you create a software team to do some of the development of these applications, you would need access to those higher power computing resources. If you are relying on a third party, it could be that they have offloaded that to a web service to handle that, and we'll talk about a few of these. Other applications that you're seeing today are in the virtual reality side, potentially 3D authoring using virtual reality-based cameras, where you have multiple lenses that are able to record stereo vision for a particular video that you're showing in virtual reality. In terms of the software that are involved, I've listed a bunch here, and we won't go into detail on these. These are ones that we're familiar with here through our various trials that we've made. Obviously Microsoft has a pretty big presence here. Autodesk has a presence. NVIDIA and Unity, which I don't list here, have very large presences, as well as other platforms for authoring content. Many of these have moved to cloud services, so these aren't actually, in many cases, they don't require the same kind of computing capability that otherwise might on a local workstation, but now a lot of this has been moved to AWS and Azure style renderings, where most of that kind of hard computations might be done in the cloud. In terms of each of these technologies, I just have like 3 of these that I thought I'd highlight in terms of the headsets, and then we'll talk about some of the other unique applications that these headsets are providing. So right now we'll focus on headset technologies. The first one that I thought I'd point out is the Microsoft HoloLens. HoloLens is in its second iteration, and I don't have it listed here when it was released. It's been some time since it's been updated. However, it is one of the cutting edge standards in terms of delivering augmented reality content to a user. So the HoloLens 2 is a mixed reality headset made by Microsoft. And it's essentially has a pass-through lens that information is projected onto. So you see here, these users have a piece of glass in front of their field of view. They can look directly through that through that glass without any major obstruction. And when the headset is on, it's projecting information directly into their field of view. And I'll show some examples of that here. This is a rendering of what it might look like from a third-person point of view. You can project avatars. If you're in a collaborative meeting, you can project 3D models for facilitating that collaboration. And this particular unit comes with a variety of sensors, from head tracking sensors, eye tracking sensors, that developers use to try and understand how the user's interacting with their environment. This one in particular has a lot of ergonomic features associated with it too. It's pretty comfortable to use, not very heavy, and it also has some versions of it for industrialized applications. I think there's an example I'm not showing here that comes with a hard hat and a Z87 rated front glass. So it can replace your safety glasses. And another benefit of it is you can wear this without having to switch out lenses. So if you wear corrective eyewear, such as I do, you can wear these. And I have one of these here in my office somewhere, and I could pull it up if I had it ready. But in that sense, it's been pretty well thought out from an ergonomic standpoint. Another one that has been released fairly recently, within the last year or so, is the second version of the Magic Leap lenses. And Magic Leap is another example of a pass-through, or an optically clear glass where information is projected digitally onto that transparent visor. So it's got similar capabilities, just some small configuration differences. I believe one of the major improvements that have been made over the HoloLens since Magic Leap 2 was released was in the brightness of the field of view for the worker that's wearing it. So again, both of these provide an immersive mixed reality experience where the unit does not need to be on in order for the worker to be engaging with their environment. The last one I thought I'd highlight is the Quest Pro. This was also released last year and is a pretty interesting platform. It grew out of the Quest lineup for Facebook and now Meta. And in this case, it's a virtual reality, originally grew from a virtual reality headset where if you remember what we were talking about with virtual reality, it's a completely immersive environment where the user is being projected information through a monitor that's built into the headset. The nice thing about these newer platforms for the Quest Pro, and there's another headset that I'm not highlighting here, but we have is the Vario XR3, is that they have high definition cameras that are built into the headset. And you can kind of see one of these right here on this gentleman's periphery here. And these cameras are capturing information about the environment and can actually pass that information directly back to the user through the headset. So even though the user's eyeset is occluded, as you see, I actually have one of these here on my desk, they have ability to render the real environment in front of the user's eyes as they're working on their everyday life. So in this case, you see this woman here on the right is working at a real desk, but is projecting artificial information into her field of view. So this is actually a pretty advanced headset. I think it retails right now at about $1,000. The other ones that I showed earlier are closer to $3,500 and $5,000 per head unit. That's just for the hardware that you're dealing with, and then of course there are software costs behind that. So I thought from these headset-based technologies, I wanted to just show just a few videos that highlight some of the capabilities of these headsets, and then we'll move on to talk about projection-based systems.
What if there was a way for employees to work together from anywhere when everything is on the line? Employees are the heart of every business. It's their resourcefulness, ingenuity, and drive that get the job done. But even the best employees need help from people who aren't there with them. Now employees on site can work side by side with experts in remote locations. In an instant, they can share what they see, lend a helping hand, walk through the process step by step, helping solve problems in real time. This is a new vision for work. Now employees can work smarter and bring in the people they need with just a tap. They can troubleshoot, repair, and perform with confidence and speed. They can move freely, pull critical information into view, and stay focused on the task. Their hands free to do the work. This is collaborative problem solving at full speed. Your people, united across time and distance, more connected, more informed, and more efficient. Now employees can work together from anywhere. They can go there without being there. This isn't the future. This is here and now.
And I think I saw on the Q&A, I'm not sure if it might be coming through choppy. If it is, I can also share, I'll share the links through Megan. So if you haven't been able to get it through this webinar, we can share that with you later. So I thought I'd highlight the telepresence capabilities of these kinds of technologies. And it's not just Microsoft that has this kind of capability, but now these other same hardware vendors and software vendors are providing these solutions for telepresence. So in this case, we saw an example where this person was engaging with a system and a control panel or electrical equipment, and having to troubleshoot it and call someone into their environment that was actually not physically in that same location. So in this case, the person who's in the remote operation or remote area can actually see the field of view of the person wearing the headset. They're basically wearing a first-person view camera of their environment, and the remote party can actually annotate the field of view of the person wearing the headset, so that these annotations, like this circle that you see here, or these work instructions that have been pulled up, have been called up by the party that is on the remote line. So these are providing unique opportunities for collaborative maintenance and repair, remote inspection, knowledge sharing and retraining. So these are all, I think, unique capabilities moving forward. Microsoft has embedded this now in Teams. So this is now a Teams functionality. So if you're in Teams, then we've done this a lot in our shop, and we invite you to come here and see it as well. You can run a Teams meeting, and actually the person with the HoloLens can join the Teams meeting and can be part of that activity. It's not it's in that sense, it's a pretty well integrated solution. I'll show another example here of dynamic and embedded work instructions, and then we'll get further along here. And I apologize if this is choppy.
Modern businesses need to constantly innovate, recalibrate, and optimize to stay competitive. Dynamics 365 Guides uses mixed reality to help workers adapt to complex scenarios in daily operations, from training to assembly to service and repair. Step-by-step instructions are easily written on PC, and then holographic parts and icons are simply picked up and placed on the machine where the work happens. Novice and experienced employees can both learn and adapt quickly while doing their tasks. The instructions move with the employees, pointing them to the tools and parts they need, showing them exactly where they need to apply them. And with easy-to-author branching, managers can account for all the variables and changing conditions of their operation, allowing employees to get up to speed faster, follow the right procedures with fewer errors, and more confidence. Managers can also leverage Guides insights to combine the data generated from doing the work with transactional data, driving optimizations and continuous improvement faster than ever before. All of this is connected to the cloud, so instructions are always up to date, allowing your employees and your business to adapt at the speed of change.
In this case, again, Microsoft has a solution here, but there are many other solutions that are available and are now offering very competitive capabilities. In this case, this particular software makes it capable for folks to actually author work instructions and training guides within a no-code environment. So there's two general approaches to this. One, you have advanced software developers that can get into Unity and the engines that are required to, the physics engines that are required to actually, or graphics engines that are required to do some of these renderings real time. Or you rely on a company such as Microsoft, and I have some other solutions that I'll show you here, where they developed a WYSIWYG, or what you see is what you get kind of approach to creating this kind of content. So we've played around a lot with Dynamics 365 Guides, and again, we welcome you all to come and try it as well. It's about as easy as using PowerPoint in that sense. You can create this kind of content somewhat intuitively without a whole lot of exposure to this kind of technology in the past. Of course, that provides some, there's usually some trade-off to that, and that would be flexibility of the kind of information that you're presenting. But the way that this kind of content is delivered is through essentially cards that you see here, prompts for the user or for the operator to click through, and they can actually use not only hand gestures, but actually use their gaze to actually select menu items and actually work through whether it be a training or these are now often used for inspection. So you might do a site inspection using the headset and actually take a lot of notes this way. This again has evolved somewhat actually just in the last 6 months or so, and now actually has Teams integration built into it, where if someone's working through a work instruction and runs into a challenge, can actually do a Teams call directly with someone that might have better understanding of it. One thing that was highlighted in the video, but maybe was only mentioned quickly, was analytics. And I think an interesting part of this is, since most of these softwares are now web-enabled, in this case, Microsoft sells this as a service, where if you're using the technology, each user will have an account. basically you're able to access data on productivity of a worker in terms of how quickly they work through the work instruction set and aggregate that cleanly into a database that is on the back end. So those are all, I think, unique aspects of these technologies because they are born in this digital format. You're able to capture digital information very quickly. So there's benefits from a productivity tracking and assessment standpoint. I think I have one more video of Microsoft, and I'm not paid by Microsoft, but I just wanted to. They have a really interesting offering from an enterprise standpoint. So I'll play this last video, and then we'll get into projection-based AR.
Connection is a spark that gives our lives meaning. It drives us to seek out others who feel the same way.
Okay, why don't you input the data and we'll take a look together. Hey Mari, what you got for me?
To find those who share our views, yet offer different perspectives.
So this net.
Look over here.
Challenge us with new ways of seeing.
That I think we should.
Deepen our understanding. And enrich our lives.
最后一笔的时候，往前。
Great things happen when we commit to something bigger than ourselves.
Take a closer look at it.
Place this here. Let's see how we go from there, okay?
This sense of collaboration and the feelings of connection it brings excites us.
Hey, just in time.
I'm gonna move it slightly, okay?
It's yours, take it.
We have 2 planes right now on the same trajectory.
As we put people first, technology fades into the background and feels like anything but.
Aisha, what do you think?
I think if we had 330, maintaining 2800,
We'll be clear for approach.
Excellent.
This changes the way we see the world, and in turn, changes the world we see.
These numbers are looking great, actually.
There's promise in the possibilities, and what we see and create next will stretch the imagination.
Good morning, Sarah.
Morning.
Slowly coming towards the thumb.
A world without boundaries.
Good job. A lot better than yesterday.
Yeah.
Excellent. Slowly bring the
A
arm
world
down.
where technology enhances, not limits, humanity. With people front, center, and in the spotlight. The future is here. And here can be anywhere. Introducing Microsoft Mesh.
So hopefully that video came through. I muted my video, so hopefully that will improve the bandwidth. This last piece of this headset-based technologies is collaboration and immersive teams. So Microsoft Mesh, which also is evolving rapidly, is just one such platform. Meta and most of these other platforms now have similar software capabilities. In this case, you can have and carry out a meeting virtually wearing this kind of hardware and work together on physical models. So you can imagine a design team that's working together to work through potentially design review or design modifications, as you might imagine many folks might do. And just imagine being in a room where you have avatars of other people that are engaged in this meeting that are physically located in space, where if you're at a boardroom table, we see this in movies, you're at a boardroom table, each one of the seats can actually be, a physical space that someone is occupying. And this provides, I think, unique opportunities for these virtual kind of collaborations, 3D design reviews. We went and tested this at IMTS, the International Manufacturing Technology Show, and showed this to a lot of the attendees. And I think it's a unique capability that we're going to start seeing more in the right places. And it's just a question of where exactly should this kind of technology go. Probably has lesser direct immediate connection to the shop floor, but it certainly is an up and coming technology that you might want to be aware of. I had a couple of videos here, just 2 last ones of augmented reality through projection and tablet-based approaches. So let me play the first one on projection. So in this case, this is actually a local Georgia a company that is actually doing work on projection technologies for assembly operations. So here you can project information directly onto a component that your workforce might be working on, and actually the work instructions get highlighted there. So if you remember from the first slide that I had, you can project information that highlights to the operator where they need to draw their attention or what kind of work they need to do, and we'll see some examples of that here. So I'll play the video and then we'll come back to it.
Light Guide Systems is the ideal visual guidance solution for automotive interior assemblies such as headliners, door liners, and center stack or IP clusters. In this demonstration, a headliner is assembled by two people working independently and asynchronously. The first step in the process is to inspect felt components, with the Light Guide system using a 3D sensor to confirm the inspection of each component and auto-advancing the work instructions until all inspections are completed. The process continues with the first operator laying down glue for foam block placement and the second operator beginning the harness installation, again working independently. Once the gluing is completed, the foam blocks are ready to be placed following the visual guidance, and once the last block is in place, Light Guide Systems again auto-advances via 3D sensor confirmation. Now, both operators work together to complete the harness installation and taping process. Visual guidance indicates where the tape is to be placed. The work is self-paced until completed. The second operator moves away to prepare for the next headliner build, while the first operator works until the harness taping is complete. When done, he touches the soft button to complete the build process.
So aside from, hopefully that came through as well, aside from the ability to project the information directly onto a work surface that the operator is working around, as opposed to referring to a SOP that might be in a binder somewhere or with a traveler, the benefit of this, another ancillary benefit of this, is that you have the ability also to mine the information from cameras that might be monitoring this process and actually highlight if someone had done something incorrectly. There's the ability to bring in, for example, in a more advanced sense, machine learning models that can identify, or computer vision models that can identify, hey, this particular cable is not routed correctly. So these are rapidly emerging, but certainly on the kind of the earliest stage adopters are using it for the examples that you've seen here. Some application areas that we're seeing this now in is certainly in assembly. So we see here an aerospace component and an operator who has to obviously attach a lot of different fasteners to a structural component for an aerospace system. And in this case, the work instructions are being highlighted. The information on where to go for that operator in terms of their next step also is highlighted. So that ideally would reduce the amount of potential defects that are created in this operation. It reduces probably the time required to realize where they need to do their operation, as well as potential opportunities for tracking the quality of this process while it's happening. Additional ones would be related to part picking and kitting. So you can imagine in some sort of a distribution facility, if someone's got to pick items from a bin, highlighting the bin that needs to be picked from is a common application that we're seeing these techniques being applied to now. And then, of course, the similar applications in training and in maintenance for that we saw out of the headset-based technologies. You can also imagine through these projection systems. I have one last one here on tablet-based AR, and then we'll end with some applications and talk about opportunities. This next set of technologies is related to how we use tablets in the factory floor. So, as opposed to having headsets on that workers are wearing or projection-based systems that might be in a work cell, we might imagine using tablets and the camera technology within tablets to augment a physical representation of a component with digital information. So here we see an example of a pump or a compressor that has annotations on it that are identifying, actions that the user needs to take. And as the user manipulates the view of the tablet, walks around their environment, those actual annotations are registered against the physical model of the component itself. So those arrows stay in place, these markings stay in place as the operator walks around. So these same technologies, this one is a technology called WorkLink from Scope AR. And this is a similar kind of platform that adopts a no-code approach where you're basically, if you're familiar with timelines and PowerPoint, you're probably pretty ready to actually do this kind of work, to create these kind of work instructions. It's a browser-based authoring platform. So again, it's a software as a service kind of approach and business model. And it has not only the opportunity to bring in remote assistance like we saw with the Microsoft application, but also it has the opportunity to do competency-based assessment. So if you're doing training, one of the things that you might want to track is whether or not the knowledge is being retained or is being transmitted well to the operators as undergone training. So keeping track of and providing, for example, quizzes that are dynamically shown to the operator are possible using these kinds of technologies. And myself, who has, it's been a long time since I've done coding, I'm able to actually go and create these kinds of work instructions, which is, I think, a testament to the approach that a lot of these companies are taking for authoring this kind of content. So last thing I'm going to wrap up with is, before we talk about some opportunities, are some of how we see it happening here and changing some of the things that we do here in Georgia for our manufacturing companies. One of the things that I've been had the benefit of being involved with is looking down at Robbins Air Force Base in Robbins, Georgia, and looking at how they do maintenance, repair, and overhaul on different kinds of equipment. And a lot of the tasks that we see in maintenance and repair is heavily manual and makes use of visual inspection from operators. How can we change those kinds of practices to actually leverage augmented reality, virtual reality, and mixed reality to enable their kind of work? So here, down in Robbins, they do all the repair for C-130 for the large airframe for the Air Force. So looking at C-130, C-5, as well as a host of other fighter aircraft. And oftentimes, what they're looking for in many of these applications is visual defects. Can we pick up cracking and different kinds of spall that might be present on these parts through service? And we have the opportunity to leverage not only the vision systems that are built into these headsets, but also the capability to pair well with cloud resources to actually do machine learning to pick up these problems. So you might imagine, if the operator sees something like you see on the right, here's a visual field. Can we highlight the defects that are present in this kind of field of view? And this is where manufacturing is going in the long run. Can we augment the capability of our human workforce with AI and having this connection to the digital, I think of as metaverse, through these headsets, these projectors, these tablets, is going to be, I think, the really exciting thing coming forward here as we start looking at how manufacturing is going to change. And this is just an example of what the models can do. Now we just have to think of the interfaces between humans and these models. With that, I'm going to wrap it up, and hopefully if there's questions or anything like that, I'm happy to take them. But this is, I think, a unique opportunity, unique time to be engaged here in the state. Georgia Tech is a leader, I think, in trying out these new technologies, and the whole goal of the work that's going on at the AI manufacturing pilot facility is really focused on enabling companies across our state, whether those be large down to small businesses, the opportunity to play with these technologies and learn about them through the workforce that we have here and the technical expertise that we have here. I invite you all to potentially come over and try these technologies. if there's a follow-on interest from the work that we're doing here, we'd also be interested in hosting a day where we potentially do authoring together with engineers in the area that might be interested in learning about authoring work instructions using this kind of hardware. And we're going to look to the community to identify the pull and interest in that. So with that, I'm going to open it up for questions. This is an example. I just had a video here of some work instructions we created for our students on training them on laser cutting. So I'll let that play as we wrap up here. But yeah, there's a lot of, I think, unique physical resources, software resources, and technical resources that I think we can offer to the membership here in the state for our small to mediums and large businesses. So with that, I'm going to turn it back over to Megan and see if we had any questions at all with the time we have remaining.
Yeah, if anyone wants to unmute yourself and ask a question, or if you just want to put the question in the chat box or the Q&A box, I can read that off to Chris and allow him to answer. I
think I had Sean's email wrong
Yes.
here, so I think most people probably saw that. So you probably could find him, and I'm happy to send if you send me a contact.
I can include that in the follow-up email as well. You will get a link to the recording of this webinar. I can also include the links to the videos. I know I think for some of y'all it was a little choppy, so we'll be sure to get the links, the recording, and any other resources that Chris would like me to share with you all. And you should receive that email either tomorrow or Monday. All right, we have a question. Let's see, from Forrest. He says, we are a Microsoft-based company. Where would you recommend we start moving solid edge / CAD drawings to an AR or MR format?
It's an interesting question. Thanks for your question, Forrest. I don't think you need to change your PLM and the way you do CAD within your facility to try and partner into these technologies. So I use SolidWorks on my work, and you're generally not using the native CAD files to actually import those into these kind of software. So in Microsoft Mesh, or even in Scope AR's WorkLink, there's ability now to import STL. However, most of where computer graphics and the virtual reality space has been is using files like OBJ files, and there are a couple other ones that are just kind of eluding me right now. But through the translators the file translators that we can get, they're really focused more on open formats than closed formats. So if you do have the 3D models, it's probably going to be some of these non-proprietary formats that you'll be able to plug in directly to this kind of ecosystem. And if anyone is interested in seeing that kind of workflow, I've had to do it myself, and I'd be happy to show folks what that looks like. But it's pretty straightforward. Some of the challenges that you do run into now that I'm thinking about it are when you do translate those files into something like an STL or a different approach, the size of the file can become pretty important. So when you look at something like the HoloLens, it's got somewhat of a small microprocessor on it. It's not, you're not wearing a Surface laptop on your head. You're wearing a much smaller graphics capable and compute capable device. So I haven't run into it myself, but I have heard that as you start going to more complex 3D models in terms of their size, that you might run into a compute limit where you have to think about the hardware that's on your head. So, but again, that's a small nuance behind that. So, yeah, hopefully it answers the question.
Any more questions for Chris?
Yeah, again, I invite. Oh, I got one more here.
Okay. Question number 2 from Forrest. We are working through AR, MR on tablets such as Surface Go 3 with rendering limitations. Are there any specifics around base device requirements?
Yeah, it's interesting. I think this space is changing so quickly. And the one thing that's much, I mean, I find very interesting is using these solutions like NVIDIA's Omniverse, which I'm not sure if you've run into, but here you can rely on cloud or non-local rendering to do the heavy lift on some of the rendering that is needed. So NVIDIA has inside of Omniverse has something like this that can actually do the real-time rendering and present it through some of your lower performance devices. So there are base device requirements for running some of these software, but even in the case of something like Guides or something like Scope AR's WorkLink, I mean, they're running it on phones. So when it comes to the presentation of the content, I think that this is being well sorted out by the software developer companies, people that are a lot more familiar with it than I am. But certainly it's something that if you are writing your own kind of software to do this on your own internal development teams, it probably is something that you're pondering. So I don't have a whole lot of like in-depth knowledge of this, but I know that there are solutions for working around some of the like local device limitations through NVIDIA. So I encourage, if you haven't seen that just to take a quick look at it. We do have an NVIDIA Omniverse license here on campus too, so it could be something that folks that are interested could try too. So thanks for your question. I see a couple more here. Yeah. So I can just go down the list. Beyond file formats, are there open standards for open source software that will help get around vendor lock in the future? Yeah, that's a big concern. And some of the companies that we've worked with have gone away from these software as a solution or as a service approaches because of vendor lock and some of the inflexibility that, as you look at your whatever production operation you're working on, the solution that's provided may not be sufficient. So in terms of open software, open development, I think a lot of those folks have gone toward Unity and actually doing their own development directly there. I can't say one way or the other whether or not there's enough work on the open standards community to kind of lead that. I think a lot of the software as a service solutions that I've seen, those are subscription services, as you might imagine. You have to pay, with Guides, we pay a monthly subscription to it. It's really about, I think the ease of implementation and not having to have that advanced development team behind you to field the solution. And I think that's where this industry, and I'm somewhat new to the industry in terms of I'm more of a practitioner, getting familiar with how we use it in our application space. But my impression is, in order for industry to adopt it, it really has to be a turnkey solution that is flexible. And I think the providers are struggling right now to figure out what balance that is, because usually turnkey means inflexible. so it's a great question. I'm not sure where it's going, but hopefully my insight on it is helpful. Thanks for your question, Matt. I see one here from Cole. AI is interesting technology, some unintended consequences. I have seen the word AI guardrails. Can I foresee the need for coding and parameters to prevent misuse? Specifically, could organizations that use AI create a vector of attack for those that want to exploit intellectual property? Yeah, I think it's a big concern. These are all basically head-mounted cameras that are sending information to the cloud. And the question is, what is the privacy considerations that you have behind that? If you look at Europe and the GDPR, which is their Data Privacy Rights Act that they've enacted, a lot of these technologies are going to stop because of GDPR in that particular application space. So I do think that this is a consideration if you are in a high consequence application or environment, defense or otherwise. You probably will have some challenges in bringing these kinds of technologies into your shop, because they are vision systems essentially that are communicating with the cloud. I think there are solutions though for deploying this locally. So in most cases, there's probably workarounds that you can find, but yeah, this is certainly a major thing that you have to think about. Thanks for your question. And then the last one I see here from Luke is, would wireframes help with hardware limitations? Yeah, I think the rendering is done locally by the device. So you know, if you're presenting it in wireframe format, I think it does help with it. I haven't run into this limitation myself in terms of that. Again, yeah, I've imported full machine models of CNC equipment. I'm a machining person, and I've imported full CNC models of our equipment and not really had a problem. So I think this might be more of a limitation that you run into in these collaborative design teams. If you're working on a large assembly that has dozens or hundreds of parts, it could be that importing that as a model tree or something like that may be pretty challenging. So I'd say that potentially for manufacturers as opposed to designers, it may be less of an issue, as I have not run into that issue myself. However, I think you know, potentially the things that you mentioned here may be important. So I appreciate your question. So it looks like we're getting close to 2 o'clock, and I see here one last question. So using Scope AR, how does the software align itself with the physical machine? That's it's a cool thing if you get the chance to come and see it. You can put a QR code, a sticker on the machine. We've done this with our, if you look at the machine that we're playing the video of here in the bottom right, there's a QR code that is sitting on the machine and everything registers against. So in the physical space, there'll be that QR code. In the virtual space, there's an anchor, and that anchor is kind of tied to where that QR code's located. So that's how the software knows to register all of this information in space. If you are doing your own developer work, you can make use of some of these open toolkits. Microsoft has a mixed reality toolkit that you can access that has some of this functionality in libraries where you can do development work. The other last thing I'd mention as we're getting to wrap up here is you can also rely on AI. So now it knows it's looking for a laser cutter. It knows it's looking for a CNC machine. If you load that model into your developer environment, it can look for that machine and register it based on what it's expecting in the virtual environment. So yeah, really exciting times for that kind of stuff as well. Okay, all right. So I don't know if there's any last questions. Great. Yeah, again, on behalf of Georgia Tech and Georgia MEP, I want to thank you all for joining. Thank Megan for organizing. And if you have interest in the technology, if you want to try it out, send me an email. If there's critical mass, we'll have a day here where we'll invite everyone to participate in a workshop to do some sort of training in this. We have about 30 headsets that we have spread out across these different technologies, and be happy to show it to you all and help you learn about the technology firsthand. So thank you again, and thanks Megan for organizing this webinar.
Thank you everybody for attending today. And yes, reminder, I will send you a follow-up email with all of this information. So thanks for joining us today, and have a great rest of your week and weekend.
Take care. Thank you, everybody.
Bye.